अस्सलाम वालेकुम। आज हमने मैट्रिक्स इन्वर्जन मेथड को समझना है। सो व्हाट इज मैट्रिक्स इन्वर्जन मेथड और फिर इसके रिलेटिवली हम एक एग्जांपल भी सॉल्व करेंगे। सो हाउ टू सॉल्व अ मैट्रिक्स इन्वर्जन question, or how to solve a given matrix into the matrix inversion method. So for example, I have given two uh, two equations, that ax plus by equals to m. This is my equation number 1, and the second equation is cx plus dy equals to n. This is equation number 2. So first we have to convert this this algebraic equation into a matrix form. So the most important thing is to convert this into how to variables x and y are separated in a column matrix, and a matrix will be a b c d. A, b, c and d. Matrices are variables are x and y, and this is m and n. Now uh, this is this matrix is my A. Let this equals to A. This x y variable is equals to x. Then this equals to B. Ax equals to B. Now we have to find the values of this x. So x equals to A inverse into B. So what is this inverse? So x equals to A inverse into B. So the value of inverse is A inverse equals to 1 over determinant of A into adjoint of A. Adjoint of A. Now putting this value in this equation, so x equals to adjoint of A divided by its determinant multiplied by B. So x equals to adjoint of A divided by the determinant into B. Now, what is the adjoint of A? The adjoint of A is replacing the, the position, replacing the position of A and D, and converting the sign of both C and D. So x equals to adjoint must be D A, and the sign conversion minus C minus B into whole of the uh, determinant. So determinant is multiplying these AD and BC and a negative sign. So this will be equals to AD minus BC. And the B, what is the B? B matrix is this one. B matrix is multiply by matrix B, that is M and N. So now multiplying x equals to, now multiplying this, or first to multiply this m and n into whole matrix, and then whole divided by this one. So first that dm minus bn, dm minus bm divided by whole determinant, or a whole of the determinant value is ad minus bc. Now minus cm plus an, minus cm plus an divided by ad minus bc. So the values of x and y, this value is x and this value is y. So x equals to dm minus bn divided by ad minus bc, and the y equals to minus cm plus an divided by ad minus bc, ad minus bc. So this is the complete method to find the variable x and y. First we have to convert algebraic notation into a matrix notation, then letting this first matrix A, the variable matrix x, and the other matrix B. Now this A must be converted into A of inverse. Now putting the value of inverse. After putting the value, just by multiplying and divide, we have find a value that x and y must be equals to these two values. Now moving towards its example. For example, I have given two equations that 2x plus y equals to 3 and 6x plus 5y equals to 2. So first to convert into a matrix form, this one 2 1, this is 2, there's 1, this is 6, and this is 5. This is matrix A. Now x and y is the variable, and it's equals to x, and this equals to b. So ax equals to b, and x equals to a inverse of b. Okay, so a inverse must be adjoint of a divided by determinant of a, then multiply by b. So moving further, first we have to find the 2 multiplied by 5 minus formula 6 multiplied by 1, 10 minus 6, this value must be equals to 4. So this is a non-singular matrix. Now we have to find the inverse adjoint by 5 and 2, and by negative side. So this is, now we have to find, just putting the values. Then as we know that x equals to adjoint of a where we hold determinant into b. So what is the x value, x and y, x and y? What is adjoint of a? Adjoint of a is 5 minus 1 minus 6 minus plus 2, sorry, plus 2, and whole determinant is 4 multiplied by 3 and 1. Now this sign, this is must be equal to this. Now simply multiply 5 multiplied by 3, 1 multiplied by minus 1, 5 multiplied by minus 6, 1 multiplied by 2, this must be equal to this one. So then 14 whole divided by 4 and minus 6 divided by 4. So 14 by 4 and minus 16 by 4. So this is 4. So 4 2s are, and 2 2s are 4, and 2 7s are 4, 1s are 4, and This minus 4. So value is 7 by 2 into minus 4. Okay, this is the value. This is the value. So this is the method to solve a matrix inversion method. That's all from this lecture.